Good morning, students. Welcome to the M.K.Jain classes YouTube channel. Today we are going to discuss class 12 CBSE board chemistry sample paper 2024. The paper is divided into 5 sections. Section A, B, C, D and E. Okay. Section A, MCQ questions are there carrying 1 mark for each. Section B, very short answer questions carrying 2 mark for each. Section C, 3 marks each questions. Section D is or case study based questions. Okay. And section E is all long answers, 5 mark for each question. So let's start our paper. Yes. Look at the first question, section A. MCQs we are going to do. First question is there. For the reaction 2x plus y, product is x2 plus x2y, what will be the expression for instantaneous rate of the reaction? Okay. Now question is asking that we have to find out expression for the instantaneous rate. Now any chemical reaction take place, we see that one. If we plot the graph, concentration and time, we observe that reactant concentration always decreases, okay, and product concentration always increases. Now, at the time of instantaneous rate, so reactant concentration is going to decrease, means it is going to disappear. So for disappearance, we put the signs negative sign. And for product appearance is there, that's why we put the positive sign. Now look at the options. First option, 1 by 2 dy dt. Now plus sign here should be negative sign, so this is wrong. Option B, there is product is concentration given but sign is negative, it should be positive, that's why it is also wrong. Now see the C option, minus dx upon 2 dt. So reactant concentration is decreasing, that's why this option is correct. So correct answer is our C. Okay, fine. Now come to the next question, question number 2. Out of the following, the strongest base in the aqueous solution is? Options are dimethylamine, B option aniline, C option methylamine, D option trimethylamine. Now, as we know, for the gaseous phase amines basicity order 3 degree, then 2 degree, then 1 degree. But here mention especially aqueous medium. As the aqueous medium comes, 3 factors affect there. We know that plus I effect, then steric hindrance factor and solvation effect. Due to these 3 effects, overall basicity is affected and the order becomes the 2 degree amine highest basic, then 1 degree, then 3 degree, then lastly ammonia. So there will be answer is or A option dimethylamine, which is 2 degree amine. Okay, clear? Now come to the next question. Question number 3. Which of the following compound will not undergo azo-coupling reaction with benzene diazonium chloride? इनमें से कौन सा कपलिंग रिएक्शन नहीं देगा बेंजीन डाइजोनियम क्लोराइड के साथ? बेंजीन डाइजोनियम क्लोराइड, we know that benzene diazonium salt is N2Cl-. Okay, if we put is cation, now phenol, aniline, nitrobenzene and anisole. In phenol, OH group is orthopara directing, aniline, NH2 group is orthopara directing, anisole, OCH3 group is orthopara directing. But in nitrobenzene, it is your electron relieving group. That one, it attracts all the electrons of the benzene. As diazonium salt is the weak electrophile, so it can't attack with the nitrobenzene. That's why answer is C, nitrobenzene. See the answer there. Diazonium cation is a weak electrophile and hence its reaction with the electron rich compound containing like electron donating group OH, NS2 and OCH3 groups. And not with the compound containing electron withdrawing group like the nitro group. That's why it will not give the reaction with the nitrobenzene. Okay. Next question we will see now. Yes, here is one graph is given there. A graph was plotted between the molar conductivity of various electrolytes. Electrolytes are here NaCl, HCl and ammonium hydroxide. With concentration, which of the following is the correct set? Now, first set, second and third you can see there. First and second are straight line graph, okay? And third one is our curved graph. And we all know that the strong electrolytes always give the straight line graph and weak electrolyte always give the curved graph. So now check the option. First option given ammonium hydroxide. Ammonium hydroxide is weak electrolyte. Now next one NaCl. Among NaCl and HCl, HCl is more strong electrolyte. So the answer is C. First graph will be for HCl. This graph for HCl. Second graph for NaCl. And third one graph is for NH4OH, which is weak electrolyte. So our answer is C1. It is the correct answer. Next question. The role of a catalyst is to change. Option A, enthalpy of reaction. Option B, Gibbs energy of reaction. C, equilibrium constant. D, activation energy of reaction. Now, what is the role of catalyst? Catalyst, it is, we flow the chart for the activation energy like that. Catalyst work is decreases this activation energy. It is our activation energy. If we use the catalyst here, then at low energy level, reaction will take place. So catalyst function is to decrease the, and this is given in the D option. Activation energy of reaction is decreases by the catalyst. Now come to the next question. Yes. Out of the following transition elements, the maximum number of oxidation states are shown by. The first is given chromium, second is given scandium, third is given iron, fourth is given manganese. Okay, and we know that atomic number is given 25. So its configuration for manganese is argon 3d5 4s2. In outermost shell, there are 7 electrons are present. So 7 oxidation states can be shown by here. So here all the answer is D, and see there for scandium that +3 oxidation state because its configuration is argon 3d1 4s2. Only 3 electrons are available for the oxidation. So +3 oxidation from chromium +2 to +6. Manganese shows from +2 to +7 and iron shows from +2 to +6. That's why highest oxidation will be shown by the manganese only. Okay, clear. Next question. The value of KH is Henry's constant. For argon gas, carbon dioxide gas, formaldehyde, methane gas, these values are given 40.39, 1.67, 1.83 into 10 to the power minus 5 and 0.413 respectively. Arrange these gases in increasing order of solubility. Okay, now we have to arrange them in increasing order of their solubility, and we all know that solubility is inversely proportional to KH. What's its meaning? Its meaning is that higher the value is KH, lower will be the solubility, and lower the value of KH, higher will be the solubility. Now check here which is having the lowest value of KH, among these all given values. You can see 1.83 into 10 to the power minus 5 is lowest one. So formaldehyde is highest soluble. Afterwards 0.413, this is for methane. So it is solubility less than formaldehyde. Then carbon dioxide gas value given 1.67. So its solubility less than methane. And lastly given argon, its value is 40.39. Very, very less soluble. Okay. So solubility we will check according to inversely proportional to KH value, this relationship. Okay, fine. Now we come to the next question. Yes. IUPAC name is given there. What is the correct IUPAC name of the given compound? Now carbon chain is given and functional group you can see there COOH, carboxylic acid group. We according to IUPAC nomenclature, we start the numbering from the functional group carbon. So number 1, 2, 3 and 4. Okay, correct. Now see there on 2 carbon, 2 methyl groups are their substitution group. So 2,2-dimethyl and 4 carbon chain butane and or suffix is oic acid. So its name will be 2,2-dimethyl butanoic acid. Its correct name will be 2,2-dimethyl butanoic acid, D option. Okay, fine. Next question now. The boiling point of alcohols are higher than those of hydrocarbons of comparable masses due to. If we compare the alkanes and alcohols, same molecular mass, why the alcohols are having higher boiling points? This is the question. Now, option A, ion dipole interaction. Option B, dipole-dipole interaction. C is hydrogen bonding. And D is van der Waals bonding. And we very well know that due to high boiling point alcohol is reason is their hydrogen bonding. So we put the reason here hydrogen bond and it is given in the section option number C. C is the correct answer, hydrogen bonding. Now come to the next question. For the reaction 2H2O2, okay, reactant giving product 2H2O plus oxygen, okay, rate equal to KH2O2, the reaction is of. Now, if we check the rate expression here, okay, it is given one reactant only. So, order, what will be the order? Order will be the first order reaction. So, it is depending only on the concentration of one reactant there. So, answer will be the A, first order reaction, this one. Okay. Now, next question is there. The compound obtained by the reaction of nitrous acid on the aliphatic primary amine is nitrous acid reaction with aliphatic primary amine. And we know that when aliphatic amine, primary amine react with nitrous acid, it generally forms the alcohol. Alcohol is your main product. So check the option in options. First option alkyl nitrile, B option alcohol, C option nitroalkane and D is secondary amine. And our answer will be B. Alcohol will be formed. Okay. Next question now. Yes. A graph was plotted between the molar conductivity using valence bond theory, VBT we are using, the complex chromium tetraamino chromium plus 3 can be described as. Now chromium is given there, okay. Which type of complex it will form there. Now see the configuration. Chromium we all know that chromium 24 atomic number, its electronic configuration will be argon 3d5 exception 1 4s1. Now here shown the +3 oxidation state. So we write chromium +3 oxidation state. Okay. So in +3, what will be the configuration now? Here 3 electrons we have to remove. So 3d3, 4s, 0 remains. Now 3d3 electrons, see there, 3 unpaired electrons are present. Okay. And ammonia, 6 ligands are there. They are giving their lone pair one by one. 1, 2, 3, 4, 5, 6. 2 d orbital, 1 s, and 3 p orbital are going to hybridize. That's why hybridization is d2sp3. Clear? Now, inner orbital d is going to utilize. That's why we call it inner orbital complex. And 3 unpaired electrons are present already. That's why what we call paramagnetic. If unpaired electrons are available, then our complex will be paramagnet. So here our first option is correct one. D2sp3 hybridization. Inner orbital complex is there. Inner orbitals are using, and due to presence of unpaired electrons, it is paramagnetic in nature. Okay, clear? Now next question. Yes, among MCQs 12 were or MCQ, and this 13 to 16 are assertion reasoning type of questions. So we will solve them. First one, assertion. Look at the assertion. Vanadium had the ability to exhibit a wide range of oxidation states. Okay. Reason is given. The standard potential vanadium are rather small, making a switch between the oxidation states relatively easy. Now it is telling that vanadium has ability to wide range of oxidation, and vanadium shows their +2 to +5 oxidation state. +2, +3, 4, 5, it can easily convert. This reason is low is reduction potential value is there. So here reason switch means to change. Oxidation state is can easily be changed from +2 to +5. So here assertion is also correct one and reason is also correct one. So what is our answer? See, check now. First option, both assertion and reason are true, but reason is not correct. See, here sequence is changed. Reason is not correct one given. So it is not correct one. Both assertion and reason are true, and reason is the correct explanation of assertion. And this reason is correct explanation of assertion. So our answer is B1 here. Okay, clear. Now come to the next question. Next assertion reasoning question are DNA has a double strand helix structure. We all know DNA is double helix structure. Reason, the two strands in DNA molecule are exactly similar. Now see the double helix structure of DNA. We write the nitrogen bases, adenine double bond with guanine, and here thymine with cytosine triple bond. Okay. Now, but you can see that here adenine, thymine, this the other strand is having guanine, cytosine, nitrogen bases. So first one statement is telling DNA has double strand helix structure. We can see this is correct one statement. But reason the two strands are similar. These are not exactly similar. They are complementary to each other. They are completing each other. Okay. So here adenine complemented guanine, thymine with cytosine. So we can't say that reason is not correct. Now check the options. Option A, both assertion and reason are true, but reason is not correct explanation of assertion. Second, both assertion and reason are true, and reason is the correct explanation, not there. Third, assertion is fake, but reason is true. It is also wrong one. D, assertion is true, but reason is false. So it is correct one. Assertion is true, but reason is false. So answer is D1. D option is correct here. Okay, fine. Now next question. Yes, next assertion. Tertiary butyl amine can be prepared by the action of ammonia on tertiary butyl bromide. Okay, this is the assertion. Reason. Tertiary butyl bromide, being 3-degree alkyl halide, prefers to undergo elimination on the treatment with a base. Okay, now we will check this reaction. See the structure of tertiary butyl bromide. Tertiary butyl bromide. Now, tertiary butyl bromide, if we react with ammonia, this reaction, then what will happen? It goes in elimination reaction. Here from halide Br and the H. Minus HBr will take place and 2-methyl propene is formed. And Sadjev rule says there highly substituted alkene will be formed first. So here reason is correct. Tertiary butyl bromide undergoes the elimination, prefer to undergoes elimination, not the formation of tertiary butyl bromide. So reason is here correct, but assertion is wrong one here. So our option C is correct. Here option C is correct. Option C is assertion is false, but reason is correct. Reason is clear. It goes under elimination reaction. Okay. Now next question. Yes, our next question is question number 16. Look at the assertion. IUPAC name of the compound. We have to IUPAC formula is given ether CH3CS, CH3O, CH2, CH2 and CH3. Okay. In assertion, this formula is given and name is given 2-ethoxy, 2-methyl ethane. Now, reason in IUPAC nomenclature, ether is regarded as hydrocarbon derivative in which a hydrogen atom replaced by OR or OAR group, where R for alkyl group and AR for aryl group. The reason is correct one. Now check the IUPAC name. It's ether is given. So here we will write 1, 2, 3. Both the sides CSC, but branching we start the numbering from here 1, 2, 3. So its name should be there. See, 2 propeoxy or 3 carbon here. So it should be 2 propeoxy propane. But in assertion name is given 2-ethoxy. It is not 2-ethoxy. No? So assertion is wrong one here. Clear? Assertion is wrong. So our option is C1, where given assertion is false and reason is true one. Okay, clear? So this type of assertion reasoning also comes where IUPAC name can be correct or not. You have to check yourself. Correct? Now see the next question. Yes, 16 MCQ we have completed. Now section B, where we will see the very short answers. Question number 17 to 21. Okay. Now, first question is there. Time required to decompose SO2Cl2 to half of its initial amount is 60 minutes. Okay. If the decomposition is first order reaction, reaction is which type? First order reaction. Calculate the rate constant of the reaction. Rate constant means K we have to calculate. And here already given half of initial concentration 60 minutes. Means T half is given you to 60 minutes. Okay. Now our formula is there. K equal to 0.693 upon T half. Put the values, the simple numerical is there. 0.693 or T half is given there upon 60 minutes. So if we remove this one and put the 10 to the power minus 3, then divide it will becomes 1.15 and 10 to the power minus 2 minutes. It will be, so we have to apply the T half formula. Half order, T half, half life of order we have to, half life we have to calculate. Now next question. Yes. Which one of the following pairs of substances undergoes SN2 substitution reaction faster and why? First option for first two options are given. Benzyl chloride, this benzyl not there, chloride and cyclohexane, it's chloride, okay? And here is given for halogen atoms. Now, first we do the first one part, okay? Look there. There CH2 primary alkyl halide because this one is your sp3 carbon, one carbon is attached 1 degree carbon there, okay? Primary alkyl halide will react faster as compared to the other substances. And here your secondary carbon, first thing there, here carbon is, two more carbon is attached, so it is 2 degree carbon and it is 1 degree carbon. And for SN2 mechanism, we all know that reactivity order is 1 degree alkyl halides, then 2 degree alkyl halides, then 3 degree alkyl means प्राइमरी हेलाइट सबसे ज्यादा देगा, फिर सेकेंडरी, फिर टर्शरी. सो और आंसर इज फर्स्ट वन, मतलब आपका फर्स्ट ऑप्शन दैट CH2 being primary alkyl halide, it will give the faster SN2 reaction, and this is secondary halide, that's why it will give it less. Look at the next part. Here is given 1, 2, 3, 4, 5 carbon. So it is iodopentane, okay? And it is chloropentane. Now, for SN2 reaction, we learn that Ri reactivity order is alkyl iodide is faster than alkyl bromides, then alkyl chlorides. Okay. So, according to this order, SN2 reaction faster will be given by iodopentane. Clear? So, here iodopentane will give SN2 reaction faster. Now, come to the next question. Question number 19. A cell is constructed between copper and silver, where copper is anode, copper is converting in copper plus 2 ion, salt bridge symbol. Here silver Ag converting into Ag ion, silver ion reduction taking place in silver. Okay. Now, if the two half cells are working under the standard condition, then calculate the EMF of the cell. And E naught value for copper is given 0.34 volt, we know that. And for silver, it is given 0.80 volt. Now, we know the E naught cell equal to E right minus E left. E right minus E left, or we can write E electrode potential of reduction, okay, minus E naught value of for oxidation. So here values are given there, put the values there only. For E naught cell, right hand side always reduction takes place and left hand side oxidation takes place in your electrochemical cell. Now, see the values there, 0.08 is given there for reduction potential, right hand side, it's 0.80 minus, then given value is 0.34, 0.34. So if you do that one, it becomes the 0.46 volt. Okay. So 2 mark question, we have to just find out the E naught cell value. Okay, clear? Now next question. Identify compound A and B in the following reaction and write the related balanced chemical equation. Okay. CH3CONS2 amide is given. In the presence of P2O5, phosphorus pentoxide, heating is going to done. A product will be done, form, then 4H and Sn plus Cl2. Sn plus HCl given means we have to do reduction, its reduction. So first reaction we see that one. If we take that one, here phosphorus pentaoxide, then here removal of water will take place. How? This what hydrogen and oxygen is going to form, remove in the form of water, and cyanide is formed. Okay. Now cyanide SnCl2 is reducing agent. Okay. So cyanide to it reduce cyanide to the amine. So what is product? Ethyl amine will be, or product will be there. So A is methyl cyanide and B is, or ethyl amine will be formed. Okay. In this one option, internal option is given or. Complete and name the following reactions. You are given the reaction RNS2 primary amine, chloroform, KOH. As you see that one chloroform and KOH, in just your mind should be clicked that it is carbalamine test, which we call the isocyanide test also. And what is main product there? Isocyanide. Only primary amines give this taste and form the isocyanides, which is having the foul smell. Okay, and second one, here amide is given. Okay, Br2NH. As you see the Br2NH, it is half mon bromamide degradation reaction, and their primary amine will be formed. See the answers. Primary amine, chloroform, and alcoholic KOH. Carbalamine test will take place. Alkyl isocyanide is formed there. Isocyanide is formed, which is that's isocyanide is formed. That's why it is known as isocyanide test also, and the we also call it carbalamine reaction. Now second one is amide is given, bromide and alcoholic NaOH. That is your Hofmann bromamide. Which reaction this one? Hofmann bromamide degradation reaction. Degradation reaction. Why we call degradation? Look at here. RCONS2 and check the product RNS2. This one carbon is removed. That's why one carbon less comes. And that's why it is called degradation reaction. Okay, clear? Both are important name reactions. Next question now. Sketch the Jupiter ion. Jupiter ionic form of alpha amino acetic acid. Alpha amino acids, Jupiter ion we have to form. Okay, and what is alpha amine? The NH2, CS2, COH, your glycine. Now one H is comes to the NH and it forms cation NH3, CS2 and CO. See the in this one, it is having the positive charge as well as negative charge. Okay, that's why it is amphoteric in nature and behave like a salt. In salt, what is acid as well as basic combine and form salt. Here also acidic group and basic group both are present. That's why it form the Jupiter ion. We call it amphoteric in nature. Next question is there. What type of linkage holds together the monomers in DNA? Monomers in DNA are linked by phosphate linkage. It is theoretical question. As it is, you have to learn. Monomers in DNA are linked by the phosphate linkage always. Okay. Now, next question there. Now, section C. 3 marks questions are there. And question number 22 to 28 or 7 questions are 3 mark each one. First question among them. A zinc rod is dipped in 0.1 m solution, okay, of zinc sulfate. The salt is 95% dissociate. Salt is how many? 95% dissociation हो रहा है. At the dilution at 298 Kelvin. आपका room temperature is given. Calculate the electrode potential. E cell we have to calculate here, okay. Now, standard E naught value is given for zinc, that is negative 0.76 volt. Okay. Now, see the only here, this is the half electrode reaction where we have taken here zinc sulfate solution. What is it? Electrolyte zinc sulfate solution. And we dipped one zinc rod in it. It is zinc rod. Okay. Half cell is given. So half cell reaction we will write down. Here zinc is taking 2 electrons and converting into zinc metal. Okay. So we can see the number of electron exchange is 2 electrons it is gaining because its oxidation state is +2. Now we got the n value. Now put in the Nernst equation for calculating E value. Here not H standard one. This is E cell, only E cell. Here not will not come. E cell for zinc electrode equal to E naught, standard electrode potential of zinc electrode 0.0591 upon 2. 2 from n, number of n value is here. 2 is coming. That's why we put here 2. Okay, clear? Now, zinc ion concentration. Now, zinc ion concentration directly is not given to you. Here mentioned 95 dissociation is going to take place. So, according to this 95% dissociation, we find out the zinc ion concentration as. So, 95% dissociation is taking place means out of 109 and our concentration is 1.1 m solution. So, we multiply by 0.1 m. So, we get the concentration of zinc ion is 0.095 m. Now, put in this one at this place, Nernst equation. Electrode potential of zinc electrode is, this value is given, standard value, number of electrons we have mentioned. Now, log 1 by 0.095. Now, 0.0, if you remove this one decimal, what you will get? Log 10 to the power 3 there. If you put the 10 to the power first, 10 to the power minus 3 and at downwards we will get the 95. Log 10 to the power minus 3, how we can write that one? This one, 3 log, if power is there, we can write 3 log 10 minus, if downwards we put the minus sign, log 95. Okay. In this way we will calculate it. So log 10 value is 1. So 3 we mention as it is. Log 95 value is 1.9777. Okay. So calculate it, then we will get the answer 0.79021 volt. So what we have to do in this type of question, first check the exchange of number of electrons, then E naught value always given to you, then put in the Nernst equation, concentration we have mentioned, then we can easily calculate the electrode potential value. Okay, clear? Now come to the next question. See the next part. Give the electronic configuration of the d orbital of titanium where the complex is hexa-aqua titanium plus 3 oxidation state, and explain why this complex is colored one. Why this complex is colored one. And atomic number of titanium is given 22. Okay. Now see the part there. Titanium, we know that scandium titanium is 22 atomic number. So we write down its configuration first. Argon, it is 3d2 4s2. Okay. In the complex given the +3 oxidation state, means it is in +3 oxidation state titanium. So what will be the configuration now? Argon 3d1 4s0. 3 electrons we will remove for +3 oxidation state. Now 1 electron is present. Here region of color is DD transition. Now what is DD transitions? Look at here. We know that degenerated d orbitals divided into 2 types of orbital that we call T2G and EG. Okay. T2G and EG we call. Now here 1 electron is present. See that configuration, 1 electron is present. This 1 electron When gain the energy, it jump to the higher state and reach to the, this time it absorb the yellow color wavelength light. Which color? Yellow color. It absorb yellow color wavelength light. Okay. And when it emit its energy and come again to the its real position T2G orbit, then it emit is always complementary color. It emit violet color wavelength light radiation. That's why this complex observe you, it is observed like violet color. Yellow color's complementary color is violet, that is visible violet color complex. Clear to everyone? Now this question has two parts. Second part, look at the second part. Write IUPAC name of compound is given, chromium, 3 ammonia and 3 molecule of water is there, then 3Cl. Now according to IUPAC nomenclature, first we follow the alphabetical order, amine and aqua. So amine come first, 3 molecule, what we will write? Triamine, triaqua, then chromium. Now chromium in, find out the oxidation, we follow the rule X. Here is oxidation state 0, water 0 and 3 chlorine is given equal to 0. So X will become to +3. Now chromium in +3 oxidation state. So we'll put the +3 oxidation state, and out of entity whatever ion is given, that is given as a here chloride. So we mention the chloride. In this way we will write the names of the complex compounds. Clear? Now next question. Draw the structural formula and write IUPAC name of all the isomeric alcohols with the molecular formula C5H12O. We are given the formula C5H12O. Its isomers we have to draw the structures. Then what we have to do? Next part, classify the isomers of alcohols given in the as a primary, secondary and tertiary alcohol. Okay, so first we draw the all the isomers, then we find out which is primary, which is second and which is tertiary. So C5H12 according molecular formula we make the 5 carbon chain. Now O is given means alcohol is there. So it is pentane 1 ol. First structure straight chain you make carbon, then 1 alcohol. Now make the branch of 1 methyl. So it is 3 methyl butane 1 ol. Again second structure. Third one we made up more branches, so it will be 2,2 dimethyl propane 1 ol. Then next structure is, now these all are 1 alcohol, then 2 degree alcohol, we change the position of OH group on 2 carbon. So pentane 2 ol. Now pentane, it is also 2 ol, but we made up the branch. More isomers are possible, 8 total. See, check the next one. See there. Now again the alcohol, it is also 2 degree alcohol. Here 2 carbon is having OH group. Next structure, it is on third one, change the position isomer we made up 3 all. Okay, now if we check the all the structure, first A, B, C, D we have seen 1 all. Okay, so they all were the on 1 degree carbon OH was there, that's why they were all primary alcohols. Okay, in structure number E and F, we have seen 2 degree carbon is having OH group, means secondary alcohol. 2 E, F and H are your 2 degree alcohol. And tertiary only G1. See there, this carbon is 3 degree carbon. 1 methyl group, 2 methyl group and 3 methyl group. That's why it is 3 degree. So among these all 4 were primary alcohols. Then E, F and H were your secondary, and only one structure is tertiary alcohol. Okay. Now come to the next question. Yes, answer the following questions. Any 3 we have to write the answer. Here it means options, internal options are given. What do you mean by depression in freezing point? First question. What is depression in freezing point? Any non-volatile substance is there. When a non-volatile substance is dissolved in a solvent, whatever vapor pressure, it always decreases there. And decrease in that freezing point is known as the depression in freezing point. So first answer is when a non-volatile, non-electrolyte is dissolved in a solvent, its freezing point decreases because non-volatile interrupt in between the vapor pressure. The decrease in freezing point is called depression in freezing point. It is directly proportional to the amount of the solute. It is directly proportional to molality. And depression in freezing point is denoted by delta TF. And we write always delta TF equal to freezing point of solvent, pure one, and freezing point of solution. So we symbolic we write delta TF equal to T naught F minus TF. Okay. Now look at the next question. How can the molecular weight of a non-volatile substance be calculated by freezing point depression method? Only give the formula. Here we have to write down only formula. And we all know that delta TF equal to Kfm. Here m is molality and molality is formula. We write down the given mass upon molar mass. Okay. And we make the formula, then very well known formula, the molecular mass of solute equal to 1000 into Kf into W given mass and given mass of solute delta TF depression in freezing point, and this capital W is given mass of solvent. Okay, here all the values are given. M for molecular weight of solute, Kf molar depression constant, which we call also what? Cryoscopic constant. We call this one Kf cryoscopic constant. Okay, and W is weight of solute, capital W is weight of solvent, and delta TF is our depression in freezing point. Okay, now third part of this one. Measurement of osmotic pressure method is preferred for the determination of molar mass of macromolecules such as proteins and polymer. Means it is asking why osmotic pressure method is more preferred over the other methods. Now, what's the reason behind it? Because in osmotic pressure, we can calculate the at room temperature. And second benefit is there, we use here molarity, not the molality. So answer is the osmotic pressure method has the advantage over the methods as pressure measurement is around the room temperature and the molarity of the solution is used instead of molarity. That's why osmotic pressure method is more preferred. Yes, fourth part of the question is there. Elevation of boiling point of 1 KCl solution is nearly double than that of 1 sugar solution. It means it is asking why 1 KCl is having the elevation of boiling point twice of the 1 sugar solution. Now see that one. Elevation of boiling point that we denoted by TB, okay, is directly proportional to I. Now what is I? I is or Van Hoff factor is directly proportional to I. I is Van Hoff. This is Van Hoff factor. Now check the KCl. KCl is ionic compound. So it dissociates in the solution and gives K plus and Cl minus. And if we compare the sugar, it is non-electrolyte. It will not dissociate in ions form. So for I value for KCl becomes 2 and I value for sugar it is 1. That's why KCl elevation boiling point becomes double than that of the 1 sugar solution. So it is because KCl being ionic dissociate into K and Cl ions, and therefore it is want of factor will be 2, and whereas for sugar solution want of factor is 1, as it does not undergo such a dissociation. That's why KCl has twice value than the sugar solution. Okay, clear? Now come to the next question. Yes, question number 26. Write the IUPAC name of the following complex. Complex compound is given. We have to write down this IUPAC name. Now, check the ligands. Ammonia is given, water is given, Cl and Cl2. Okay. Now, again the sequence tetraamine. Here, water is only one is given. So, aqua, then chloro. We arrange them as alphabetical order. And cobalt oxidation which state we find out. See there, for ammonia 0, water 0, Cl4 plus 1, here Cl2 plus minus 1, here minus 2. So overall X will become plus 3. For cobalt oxidation state comes 3. So cobalt 3 and ion is given chloride. So we write down as it is chloride. Now next part of the question. What is the difference between an ambidentate ligand and bidentate ligand? Ambidentate ligand which has two donor site, same molecule, two donor site is there. And bidentate means which ligands which form two bonds. See the example there. A ligand which has two different donor atoms like CN, cyanide, it can form bond from the, but at a time it form only one coordinate bond. CN, N can form bond, or that carbon also can coordinate bond. So this type of ligands are known as the ambidentate ligands. But only one of them forms a coordinate bond at a time with the central metal ion. It is called ambidentate ligand. On the other hand, ligand which can bind through two donor atoms like ethylene diamine, these are bidentate ligands which can form two coordinate bonds. Next question. Two complexes are given, iron with hexa amino iron, and here given trioxylato iron. Which complex is more stable and why? Now stability depends on the type of your ligands. Here amino ligands are there, here oxalate. And now oxalate are your chelating ligands, and we know chelating ligands cover the whole central metal atom from all the side, and that structures are more stable. So trioxylato iron complex is a chelate complex, and then the hexa amino iron is a complex containing unidentate ligand. So this complex, oxalato complex, will be more stable. Okay, clear? Now next question. Question number 27. What happens when N-ethylamine react with the benzene sulfonyl chloride? Second is asking benzyl chloride is treated with ammonia followed by the reaction with chloromethane. And third is asking aniline reacts with chloroform in the presence of alcoholic potassium hydroxide. Now see the reaction first one. When N-ethyl amine reacts with the benzene sulfonyl chloride, NN diethyl benzene sulfonide is formed. So we draw the structure benzene sulfonyl chloride. What's its name? It is Hinsberg reagent. SO2Cl. Benzene sulfonyl chloride is Hinsberg reagent. Its reaction with your ethylamine and ethylamine. So C2H5. Here you write the NH2 and C2H5. Here HCl will remove, as the Hinsberg test we write down, minus HCl will take place. Okay. Now form the formula. This your ring, benzene ring, as double bond O, here also as double bond O, and here is N C2H5, C2H5. So what is the product? Look at here. N and diethyl benzene sulfonamide. See that. N and diethyl benzene sulfonamide will be formed. Okay. Now second one, benzyl chloride. As you see the name, first write down the formula. Benzyl chloride, we first form the benzyl chloride. CH2 Cl is benzyl chloride. Now is treated with ammonia. Ammonia is NH3. So you do the reaction. Here HCl will be removed minus HCl. What will be the product? Here your benzyl group you make CH2. Okay. Now HCl is removed and NH2 is HCl. So what is benzyl amine? Now further it is telling them benzyl chloride is treated with ammonia. Okay, we form the benzyl amine, followed by the reaction with chloromethane. Further it is reacting with chloromethane. Chloromethane is ClCH3. Again remove HCl from here. So product will be again form the benzyl group here. CH2, now NH and your CH3. So what we call N-methyl benzyl amine. See the product. When benzyl chloride is treated with ammonia, it forms benzyl amine first, which is on reaction with the chloromethane forms the secondary amine N-methyl benzyl amine. See the structure of N-methyl benzyl amine. Next part is asking aniline reacts with chloroform in presence of alcoholic chaos. As you see the aniline reaction with your chloroform and alcoholic KOH. It is always carboamine reaction, or we call it isocyanate test, in which primary amine is formed. So draw the aniline. Aniline is benzene ring on its NH2 group. Then its reaction with chloroform CaCl3 and alcoholic KOH. In that question, we have seen aliphatic amine, primary amine. Here we will see aromatic amine and its isocyanide test. See, here isocyanide, benzene isocyanide will form. So only primary amines give this test, and isocyanide is formed, which is foul smelling. In practicals also you do this test. Now come to the next question. Question number 28. How will you convert ethanol? First, see the what they are giving to you. First, you have to underline always while solving this type of question. Ethanol means you are given the aldehyde, okay? To the following compounds. What we have to make? Butane 1,3-diol. All means aldehyde, we have to convert it into alcohol. Then it is saying butane 2 in L. L means double bond and aldehyde group both will be there. And third one is 2 in oic acid, means double bond will be also there and carboxylic acid group also will be there. As is you see that ethanol means aldehyde given, and in product it is asking butane means double, twice we have to do. Or aldehyde reaction means where we do this twice of carbon atoms in aldol condensation. So it should be come to in your mind that it most probably it will be aldol condensation. In aldol condensation, what we will do? Two molecules of aldehyde we will take CH3CHO, one more CH3, and you write down in this way, so it becomes easier to form the product. One H from here come to the with oxygen. So look at here, CH3 as it is, CH and OH, it is CH2CHO. Now third carbon is having OH, 3-hydroxybutanol. That's why we call it as aldol. Aldol means aldehyde group plus alcohol. From alcohol, OL is taken. That's why it becomes like aldol condensation. Now, look, here you have to think that aldehyde is given, one OH is given, and what we require in our main product, 1,3-diol, means two OH should be there. So we have to convert ultimately CHO group into OH. How we can do? By reduction. Aldehydes can be converted into alcohols by reduction. And our most common reducing agent is lithium aluminum hydride. Lithium aluminum hydride is, so CHO is converted into OH group. In this way, we can form the butane 1,3-diol. Yes. Second is asking ethanol to butane to in L, means double bond is also there and aldehyde group is also there. And we have just done the aldol condensation, same thing is there. Two molecule of ethanol we will take CH3, C double bond O H, acetaldehyde. Next one is also acetaldehyde. From here, one H comes here. See, the same addition is going to take place. CH3, CH, OH, CH2, CHO, and again the aldol is formed, OL and ALD, aldol is formed. When we heat them, minus OH from here and one hydrogen will remove from here. So yeah, this is your double bond comes and aldehyde group remains as it is, and this form your 3-hydroxy, that one this is 3-hydroxybutanol. From this one heating is done, then water will remove, and our last product of aldol condensation is but2 in L. Okay, so it is this reaction. Second one is directly asked only for aldol condensation. Third one, but2 enoic acid. From ethane acetaldehyde we have to form the but2 in oic acid. Now ethanol to this but2-enol we have just formed by the aldol condensation. Now it is asking the aldehyde group is there, but we have to form the acidic group. So what we will do to convert aldehyde into the acid? We do the oxidation process. And our good oxidizing reagent is Tollens reagent. Tollens reagent we will take CH3, CH double bond, CH, COOH. Okay. So aldehyde, oxidation of aldehyde group take place and it convert into acid and it forms a but2 in oic acid. So if you little bit think after seeing the question, you can easily form the product there. Okay, fine. Now come to the next question. Yes, now section D has come, which is our case study based questions. Now look at the paragraph. It is given from chemical kinetics chapter. The rate law for a chemical reaction relates the reaction rate with the concentration or partial pressure of the reactants. Okay. For a general reaction, A plus B gives C with no intermediate step in the reaction, its reaction mechanism, meaning that it is an elementary reaction. The rate law is given by R equal to K, A power X, B power Y, where A and B express the concentration of A and B in moles per liter. Exponents are X and Y. Exponents X and Y vary for each reaction and are determined experimentally. Okay. The value of K varies with conditions that affect reaction rate, such as temperature, pressure, surface area, etc. Okay. The sum of these exponents is known as overall reaction order. A zero order reaction has a constant rate that is the independent of the concentration. Zero order independent from the concentration. First order reaction depend on the concentration of one reactant. A reaction is said to be second order when reaction constant depend on the two reactants. Once we have determined the order of the reaction, we can calculate the initial value and we can solve the value of K, and we know that formula for zero order first order reaction. This paragraph is given. Regarding to this one, now questions are given. See the questions now. Yes, after that paragraph, case, the first question is asking, calculate the overall order of a reaction which has the following rate expression. Now you are given the rate expression. Here rate is given K, A, its exponent is given here 1 by 2, and here is given 3 by 2. And asking the order of reaction. So we know that order of reaction is equal to the sum of the powers of that one. So 1 plus 2 plus 3 by 2. Okay. Take the LCM 2 and it becomes 4 by 2. So overall order of reaction becomes 2. Okay. So our answer for this one, calculate the order of reaction, it becomes 2. Now next part of the question, what is the effect of temperature on rate of reaction? We know that as we increases the temperature, rate of reaction also increases because kinetic energy increases, the that collapse of the molecules increases, that's why rate of reaction increases. So what exact answer line we should be see the next one. Then next part is given here, internal option also given for question. First order reaction 77.78 minute, 50% completion. As the 50% completion given means T half is given to you. T half value is 77.78 minute. Calculate the time required for 30% completion means 100 T half 50% के लिए इतना है, 30% के लिए हमें calculate करना है. Or log value is also given to you question paper. In board exam also it is given to you. Log 10 equal to 1 and log 7 is equal to this one. Okay. और इसी के और में question क्या है? A first order reaction has a rate constant 1. K की value given है 1 into 10 to the power minus 3. How long? अब देखो per second 10 to K equal to given 1 into 10 to the power minus 3 second inverse per second. As you see the unit, you should identify the order of reaction. It is first order reaction. How long will 5 gram of this reactant take place? Reduce 3 gram. अब इसमें initial concentration 5 gram, final दे रखा है 3 gram. Okay. So you have to again calculate that one. How long will time we have to calculate. Now see the solution there. First one we will see for third part, that is T half is given 77.78 minutes. For 50% completion, for 30% we have to calculate. That I have already done for you. Overall order of reaction, here not plus sign, it is equal to. Rate of reaction increases on increasing with the temperature. I explained that. Now, T 50% completion means T half is already given to you, and T half formula is 0.693 divided by K, and T half is given 77.7 minute in the question already given. Now we have to calculate K value, so just put the values 0.693 divided by 77.7 and it becomes 0.009. It is for 50% completion. Now for 30% completion, we have to calculate as 100% and 30% completion. X means 30% completion is going to complete. So 100 minus, we put the value. This is your first order calculation part, first order K constant calculation part. So 100 minus 30, we calculate easily there. Now log 10 and log 7, and already their values are given. Log 10 equal to 1 and log 7 is given in the question. So we can calculate the value, that will become 39.66 minute. It will be the answer. Okay. In this question, in percentage, 50% already completed, then we have to calculate for 30%. In next question was given that 5 gram initial concentration and final concentration was given 3 gram. So A naught for initial concentrate was given 5 gram. This is over one question. Okay. Final concentration is 3 gram. Okay. Now, and K value is also given in the question. 1 into 10 to the power minus 3 per second. Okay. Now, write down all the values in the formula. T equal to 2.303 K log A naught initial concentration upon final concentration, first order formula. Now, K value is given. We put the K value. Initial concentration 5, final concentration 3 gram. We have mentioned as it is. Now calculate the log 5 and log 3. Log 5 value is your 0.6990 and log 3 value is 0.4771, and if we calculate it, we will get 511 second. So we can easily solve this type of question by just putting the values in the formula, and we can calculate, and log values will be given to you. Okay. Now come to the next question. Yes. Now next paragraph, it is relevant to your biomolecule chapter. Amino acid relevant paragraph is given. See the what is written in paragraph. An amino acid is a compound that contains both carboxylic group and the amino group. Although many types of amino acids are known, the alpha amino acids are the most significant in the biological world because they are the monomers from which proteins are constructed. All the proteins are formed by the amino acids. A general structural formula of an alpha amino acid is shown in the figure below. It is given there RCH, then see there COH carboxylic acid group and amino group, unionized form. And we can write down like this one, it forms the deuterion. We have just discussed the deuterion. One hydrogen of carboxylic acid group with the NH2 group that get the positive charge, and here becomes the negative charge. So it reacts as a salt. It is internal salt, which we call what we call deuterion. Okay, it is an alpha amino acid. This paragraph, in this paragraph, these all things give next part of the paragraph. Although figure A is a common way to writing structure formula of amino acid, it is not accurate because shows acid and base within the same molecule. Both the groups are present. These acidic and basic groups react with each other to form a dipolar ion or internal salt. Figure B, which we have seen just now. The internal salt of an amino acid is given the special name deuterion. We know that we call them deuterion. Note that the deuterion has no net charge because positive, negative, both charges, they both cancel out with each other. It contains one positive charge and one negative charge. Okay. Then written because they exist as deuterions, amino acids have many of the properties associated with salts because deuterion behave as a salt. They are crystalline solids with the high melting point. Now their properties is mentioned. Jupiter ions are crystalline solids having high melting point and fairly soluble in water, less soluble in water, and but insoluble in non-polar organic solvents such as ether and hydro. These are organic solvents given. Next part, according to the above passage, answer the following. This whole passage was given. Now we have to give the answers of the questions. The first question is there. Amino acids are usually colorless, crystalline, solid. They behave like salt rather than simple amine or carboxylic acid. Why amino acids show such a behavior? We have just seen the reason here why amino acids behave like a salt, because in amino acids it has one positive charge, one negative charge, and no net charge is there and behave like the salts. So we will see the written answer also one by one. Amino acids are essential and non-essential depending upon their need. Yes, we know that one. One of the essential amino acid is lysine. Can you say the why lysine is the considerable as essential amino acid? Next question. Here are given some amino acid: lysine, tyrosine, glycine, alanine. Okay. One of these amino acid is not optically active. We have to check it is optically active or not among them. Which one is that amino acid? Also provide the reason why it is optically active or not. Reason we also to give. Now internal choice given among the question number 3rd and 4th. Okay. The pK and pKb of an amino acid are 2.3 and 9.7 respectively. What would be the isoelectronic point of the amino acid? Calculate by defining it. Now see the answers one by one all. See that as we have seen in the paragraph also, amino acids behave like salts rather than the simple amines due to the presence of both COH, this is H carboxylic acid group, and basic amino group. Okay. So this reason you have to write that both the groups are present, that's why it behave like a salt. Lysine is considered as essential amino acid as it cannot be formed in the body. Those amino acids which our body can't prepare, we call them essential amino acids because we have to take it from outside. It cannot be formed in the body and has to be supplemented to the body through the diet. Only from diet we can take them. Okay. Now, among the given amino acid, glycine is not optically active. There was given glycine, then tyrosine, alanine, that all. If we check the glycine is simplest one, first amino acid. We draw this formula. It is the only amino acid which is not have a symmetrical carbon and atom is the simplest amino. We will form this formula. There CH, then COH and their NH2 group. See there, carbon, the two H atom are here similar. So it is not having the unsymmetrical carbon atom. That's why it is not optically active. That is must condition for becoming any organic compound optically active. There should be asymmetric carbon. In glycine, this is the formula of glycine. We write the NH2, this is NH2, CH2, COH. What is it? Glycine. So glycine is the amino acid that is not optically active because it is not having the asymmetrical carbon. Okay. The next part. The isoelectronic point is the pH at which the amino acid does not migrate in an electrical field. So isoelectric point is a point where amino acid don't migrate from its position in electrical field. This means that it is the pH at which the amino acid is neutral. Okay, at this pH amino acids become neutral one. That is the Jupiter ion form is dominant because they form the Jupiter ions. Now how we calculate the isoelectric point? See there, pK value plus pKb value divided by 2. In question, pK value was given 2.3 and pKb value given 9.7 divided by 2, it becomes 12 divided by 2 means here isoelectric point for amino acid is 6. It becomes 6. So the isoelectric point of the amino acid is 6. It will not migrate from this value in electrical field. Okay, clear? Now come to the next question. So we have completed both the case study based both the questions in section D. Next one. Now section E, where we will have long answer. Long answer, 3 questions will be there and there or options will be also given there. See the first question. Question number 31 to 33 is long answer questions. First one. The cell in which the following reaction occurs. Reaction is given there. Fe plus 3 iodide ions giving the product iron plus 2 and iodine. Okay, so iron plus 3 to going iron plus 2, its reduction is going to take place. Iodide ion in minus oxidation state to 0 oxidation iodine gas, it means its oxidation is going to take place. So whenever you observe the reaction, first check the which element is going to oxidize, which element is going to reduce. Now, E naught cell value is given for the cell 0.236 volt at 298 Kelvin. Calculate the standard Gibbs energy. Gibbs energy we have to calculate here. Okay. For the cell reaction where 1 Faraday value we know that 96500 Coulomb per mole. Okay. Then second part is asking how many number of electrons flow through a metallic wire if the current is given 0.5 ampere. Okay, is passed for time 2 hours. 2 hours के लिए 0.5 ampere current is flowing. Then we have to calculate number of electrons we have to calculate. For this one again Faraday value is given 96500 Coulomb per mole. Third part of the question, explain the following with reasons. Chlorine can displace iodine from Ki solution, but iodine cannot displace bromine from KBr solution. Comparison is asked. Then following reaction is possible or not. Mercury with sulfuric acid, HgSO4 or hydrogen. This reaction is it possible or not? We have to calculate. Now first part of the question we will check where the equation is given, E naught cell is given, we have to calculate Gibbs energy. We will calculate Gibbs energy. Gibbs energy formula, standard Gibbs free energy is given by the expression delta G naught equal to minus NF E cell. We know this formula. N for number of electron exchange in the reaction, F for Faraday value, E naught cell is already given in the question. So just put the values. N for number of electrons, F for Faraday constant, and E naught cell is cell constant. Now, how we calculate this number of electrons? By looking at this reaction. See there, Fe plus 3 going to Fe plus 2. Now, 2 electron exchanges for balancing, we put the 2. So, 2 electrons going to take place. That's why N value becomes 2 here. 2 moles of electrons are involved in the reaction, hence N value becomes 2. N की value क्या आएगी 2. Now put the value there only of here N2 Faraday value or E naught value is given. So what will be the answer? See there. We have written N value 2, Faraday value 96500, and this E naught cell value is given already in the question 0.236. If we solve it, we will get the Gibbs energy value. Joule we have but we make in kilojoule, convert into kilojoule. So 45548 joule. If we convert into kilojoule, put the decimal. So 45.55 kilojoule Gibbs energy will come. Now first part we have done of question. In second part, current was given. Current was given there. 0.5 ampere current is passing for 2 hours. Time was given 2 hours. Okay. Now we all know that charge passed equal to I into T, Q equal to I into T, I for current and T for your time. Current is given 5 ampere. Okay. Time is given 2 hours. So put the value. Now time is given 2 hours. We convert into second. 1 hour 60 minutes. 1 minute 60 seconds. So we multiply by again the 60. So overall it convert into seconds. So charge will come here 3600 coulomb. Okay. Now, but here we calculated the charge. Here asking how many number of electrons. Number of electrons we have to calculate. Charge equal to NE also there. Now we have to find out N for number of electrons, E for charge on electron. Now we have to calculate N value, number of electrons, Q upon E. Charge we have calculated 3600 coulomb, and 1 electron charge is 1.6 into 10 to the power minus 19 coulomb. It is fixed value. So if we calculate it, we will get the number of electron is 2250 into 10 to the power 10. In this way, we have to solve number of electrons, or in short form, we take out 2.250 into 10 to the power 22. Okay. It is 10 to the power 19. Next part is there. Chlorine, why the chlorine is there? Replace that one, Ki. Now, chlorine is a stronger oxidizing agent. We know that in comparison to, if compare the KCl and Ki, chlorine is a stronger oxidizing agent as compared to iodine. Okay, because it is standard electrode potential is lower than that of the iodine. So, chlorine can easily displace the iodine from Ki. See this equation, potassium iodide with chlorine. Chlorine is good oxidizing agent, so it displaces I from the Ki and it forms the KCl. Okay. Now if we compare the iodine and Br, then bromide. Iodine is a weaker oxidizing agent than compared to the bromine. The highest oxidizing agent is in this one Cl, then Br, then iodine. So here asking the for iodine and Br comparison. Iodine is a weaker oxidizing agent than the bromine because the value of the standard electrode potential of bromine is lower than that of iodine. Okay. So iodine cannot displace bromine from the KBr solution. If we take KBr solution and react it with iodine, as iodine is lower oxidizing agent than the Br, that's why it can't displace the Br and no reaction will take place. Here no reaction possible there. Then next part was asking, is it possible mercury H2SO4? Now we all know that if we see the reactivity order of matters, here hydrogen comes, then lower ones here copper, mercury, silver, gold, they all come, platinum. So mercury is less reactive than hydrogen. Then how the mercury can replace? Mercury metal and this all copper, silver, gold, platinum, they are least reactive metals. They can't displace the hydrogen gas from the acids. That's why this reaction is not possible exactly. Mercury can't replace hydrogen gas from the sulfuric acid. See the writing part of this answer. This reaction is not possible, as I explained just now. Mercury is less reactive. Not possible because the standard electrode potential of mercury is lower than that of the hydrogen. It becomes below the hydrogen. However, according to the electrochemical series, only those metals can displace hydrogen from the dilute solution of hydrochloric which have the standard electrode potential higher than that of hydrogen. Which are just above the hydrogen, they all can displace the hydrogen from the acids. Which are lower the hydrogen, they can't displace the hydrogen from acids. This is the reason. Okay. Now come to the next question. Question number 32. Account for the following. Account for the following means give the reason for the following statements. First one, transition metals from the large number of complex compounds. Why transition elements form the large number of complex compound? Okay. Second, the lowest oxide of transition metal is basic. Okay. Whereas highest oxide is amphoteric or acidic. Lower oxidation state one is basic in nature and higher one is amphoteric or acidic in nature. We have to give the reasons. E naught value for the Mn plus 3 to Mn plus 2 couple is highly positive. Its value is positive as compared to chromium plus 3 to chromium plus 2. Why Mn plus 3 conversion shows the higher E naught value in comparison to chromium? Then write one similarity and one difference between the chemistry of lanthanoids and actinoids. We have to write down similarity and one difference between the lanthanoids and actinoids. Now we will see the one by one all the answers. See the first one. That why D block elements form the number of complex compound due to the comparatively smaller size. We see that as in D block elements we move from left to right, size decreases, atomic radius decreases. So smaller size of the metal ions, metal ions की size कैसी होती है? Small. High ionic charge is high there, and the availability of D vacant D orbital. It is most important feature there for D block elements. Vacant D orbitals are available there for bond formation. That's why transition metals form a large number of complex compound, and all the complex compound we see there that formed by the D block elements due to their smaller size, high charge, and the presence of vacant D orbitals. Clear? Now, next question was lower oxidation states are basic and higher oxidation states are amphoteric or acidic in nature. What's the reason? In lower oxidation states, transition metals behave like metals, okay? And metal oxides are basic in nature. Transition elements behaves like a metals, like our alkali metals. That's why they are basic in nature here. Thus, in lower oxidation state, transition metals oxides are basic. इसलिए वो basic nature के होते हैं. ठीक है? Now, as the oxidation state increases in D block elements, we see that up to plus 7, like 7 or 8, they show the oxidation state. It is metallic character decreases due to the decrease in size. Higher the charge on the ion, metallic ion, that one lower will be the size. Because इतना electron release करने के बाद number of shell decreases. So decrease in size, thus it becomes less metallic. As we move from left to right, size small होती जाएगी और metallic character decrease होता जाएगा. Or more non-metallic character increases, and we all know that non-metallic oxides are acidic in nature. Or so oxides of non-metals may be acidic or neutral. Okay, thus in higher oxidation state, transition metal oxides are amphoteric or acidic in nature, and in lower oxidation state they are acidic in nature. Now next part is there. There asked their Mn plus 3 and Mn plus 2 E note value, comparative high E note value for Mn plus 3 ion to Mn plus 2, and it is having higher value, and chromium plus C2 plus 2 ion has, because here Mn plus 2 ion is more stable because in Mn plus 2 what will be the configuration? Configuration will be, as we know, Mn is 3d5 4s2 in plus 2 oxidation state, it convert to the 4s0. Okay. Now 3d5 half filled configuration is more stable condition, half filled configuration. Half filled configuration is more stable condition in comparison Mn3. That's why Mn2 is more stable, and that's why it is having high E note value. Okay. Now we compare chromium. Chromium in plus 3 is more stable. Chromium is having plus 2 oxidation state. Chromium is your 24 atomic number, that is 3d5 exception 1, 3d5 4s1. Now it is ground state configuration. If we remove 3 electron, 1 from here and 2 from here, it remains 3d3 in plus 3 oxidation state. 3d3 4s0. Now 3d3 means T2G. अब T2G में 3 electrons रहेंगे, that is also stable condition in comparison to chromium plus 2. 3d3, T2G, 3 electrons are available, that is more stable condition. That's why Mn in plus 2 oxidation stable, chromium in plus 3 oxidation state more stable condition for. So the comparatively high E note value for Mn plus 3 is due to the fact that Mn plus 2 is quite stable, whereas comparatively low value for chromium plus 3 to chromium plus 2 is because of the extra stability of chromium plus 3. T2G configuration. Therefore, chromium plus 3 cannot be reduced to the chromium plus 2. It wants to become only in plus 3 oxidation state, not in the plus 2 oxidation state. So, generally chromium, what we write, plus 3 oxidation state. Now, come, I think that is clear to you. Now, next question is there. This question having one more part, that similarity and difference in the lanthanoids and actinoids. Both lanthanoids and actinoids elements show common oxidation state is 3. We know that one, that show the plus 3 oxidation state commonly. Both are electropositive. They have nature to donate electrons. Very reactive. They are very reactive elements. Now, what is difference between them? Lanthanoids have less tendency to the formation of complexes, less complex formation, whereas actinoids have greater tendency to form complexes. Actinoids की ज़्यादा nature होती है complexes form करने की, lanthanoids की कम होती है. This is the difference among them. Okay. Now next part. How is the, now internal choice question is this one. How is the variability in oxidation state of the transition metals different from the p block elements? Now here ask the difference between p block and d block. P block we study their inert pair effect, and here we see the decreasing in size continuously. We form the chart, that one. In that one, first part question, second part of question, out of copper plus means cuprous and copper plus 2 cupric, which ion is unstable in aqueous solution and why? Next part of question, orange color of dichromate ion change to the yellow color when treated with the alkali in basic medium. Next part of the question, chemistry of actinoids is complicated as compared to the lanthanoids. Give two reasons. Two reasons हमें बताना. Now see the one by one, there are answers there. ऑक्सीडेशन स्टेट बताना है, डी ब्लॉक एफ ब्लॉक का कंपैरिजन, फिर कॉपर प्लस कॉपर 2, और फिर डाइक्रोमेट आयन इन एल्कली मीडियम कन्वर्ट्स हाउ दैट वन, एंड chemistry of actinoid is complicated in comparison to lanthanoid. Now see the answer one by one. The variability in oxidation state of transition metal is due to the incomplete filling of d orbitals. As we have just seen, vacant d orbitals are available in such a way that their oxidation states differ from each other. Variable oxidation state is shown by d block elements. For example, iron plus 2 and iron plus 3. The most of show the variable oxidation state. In case of p block elements, the oxidation state differ by units by 2. Their maximum difference is 1 or 2 there. For example, plus 3 and plus 5, plus 3 to plus 5. Moreover, in transition elements, the higher oxidation states are more stable. We have seen Mn shows up to plus 2 to plus 7 for heavier element in a group. For example, molybdenum plus 6 oxidation state is more stable than chromium plus 4. So higher oxidation state is more stable. In case of p block elements, in p block elements, the lower oxidation state is more stable. For heavier members due to inert pair, there is inert pair effect is applicable. That's why we have seen lower oxidation state becomes more stable. For example, if we compare the lead plus 2 and plus 4, so lead in plus 2 oxidation state is more stable than its plus 4. So this is the difference between the p block elements and d block elements, their oxidation states. Okay, clear? Next, now we have to compare copper plus, if plus 1 oxidation state we call cuprous, plus 2 is cupric. Now copper plus ion is unstable in aqueous solution than copper ion. In aqueous medium, copper plus 2 ion is more stable. What's the reason? This is because although second ionization enthalpy of copper is large, see there, copper, if we remove one electron, Cu plus 1 is formed. If we remove two electrons, Cu plus 2, we have to give more energy. But what's the reason Cu2 plus more stable? But hydration enthalpy of Cu2 plus is much more negative than that of copper. This is the main point of this answer. Is more negative than that of copper plus, and hence it is more stable, more than comparable for the second ionization enthalpy of copper. Therefore, copper plus compound are unstable and in aqueous solution and undergoes disproportionation reaction. And you can see the disproportionation reaction, copper plus, it convert into copper plus 2 and copper metal. The reaction in which more than one oxidation state of element is available, we call that disproportionation reaction. And you can see here copper plus 1 is converting into copper plus 2 as well as copper metallic oxidation state 0. Okay. Now third part is the answer. Yes, orange color of dichromate. We know the potassium dichromate, we get the dichromate ion. Ion change to the yellow color when the treated with the alkali. Alkali means basic medium. Because of the formation of chromate ion. Cr2O7 minus 2 charge, what we call dichromate ion, which is orange in color. If we provide that basic medium to it, it just convert into chromate ion, CrO4 minus 2 charge. Okay. So, and chromate ion is having yellow color. That's why this color change takes place. Clear? Now, look at the next part. Yes. Chemistry of actinoids is complicated as compared to lanthanoids because of the following reasons. First reason what we will give, actinoids show wide range of oxidation state. Actinoids plus 3, plus 4, plus 5, plus 6, all the oxidation state show. And in lanthanols we see only shows the mostly plus 3 oxidation state. Due to, now why they show this much oxidation state, plus 3 as well as 4, 5, 6 all? Because here is the, due to small energy difference between 5f, 6d and 7s. Energy difference between these orbital is very less. That's why electrons, we can remove the electron from 7s as well as 6d from 5f. That's why they show there how many number of oxidation state, subshells of the actinoids. This is the main reason. Second reason, actinoids are radioactive due to that their chemistry is complicated. And we all know actinoids are the radioactive elements and which are not stable. They are continuously going to divide. So very complicated. The study is also very complicated one. Now next part. Last question is there, 33 question. Write the product in the following reactions. Now see there, C double bond O, ketone is there and SCN. It is, when you see that one ketone is given SCN, which reaction is there? Nucleophilic addition reaction. Here given that carboxylic acid, sodium salt of benzene, then given NaOH plus CaO. It is your soda lime. And whenever we heat them with soda lime, decarboxylation reaction takes place. And here alkene is given DIBAL, diisobutyl aluminium hydride, and it is the reaction for formation of aldehydes. Now see the answers. And more part of question, give the simple chemical test to distinguish between the following pairs of compound. We have to differentiate between butanol and butane 2-on, means aldehyde and ketone. So aldehyde and ketone chemical test to distinguish them. Benzoic acid and phenol. One is acid, one is alcohol, phenol. So for the chemical reactions is there. Yes. Cyclohexanone, we know that ketone is there. HCN, cyclohexane react with hydrogen cyanide, forms cyclohexanone cyanohydrine. Most common reaction, nucleophilic addition reaction, where C double bond O, this carbonyl group, where HCN addition reaction takes place at convert into OH and CN. This group convert into OH as CN. And what we call here cyclohexane ring given. So cyclohexanone cyanohydrine will be the product. Next, sodium benzoate is given. NaOH plus CO, what we call is soda lime. Okay, in the presence, when sodium salt of substance organic compound heated in the presence of soda lime, decarboxylation reaction takes place and this whole CO group is converted into that sodium carbonate form and benzene will be formed here. Okay. Next, bu2 in 1 nitrile, nitrile CN group, okay, double bond. This reaction is used to form aldehydes. Here DIBAL, this reagent is diisobutyl aluminium hydride and followed by the reaction with water. So here the bu2 in 1L means double bond also present and aldehyde group is also present. This reaction is used to form the aldehydes. Okay, clear? Next part of this answer. Yes. Butanol being an aldehyde. Now here I ask the butanol and your butanone. Differentiate with the chemical test. And we all know that aldehydes give the tolerance test and ketones don't give the tolerance test. So we differentiate with them tolerance reagent. Now what is the tolerance reagent? Tolerance reagent is ammonical silver nitrate solution. which is good oxidizing agent. In the presence of tolerance reagent, aldehyde oxidize into the acid. Here butanol, see the tolerance reagent, silver, ammonia, that one, and complex compound that we call it ammonical silver nitrate solution. Oxidizes aldehyde into butanoic acid and silver mirror is formed. So in presence of butanol, silver mirror will form, and if we take butanone and tolerance reagent, no silver mirror will be formed. So in this way, we can distinguish between the butanol and butanone, aldehyde and ketone. Okay. Now next part, yes, differentiate between benzoic acid and phenol. And phenol's most common reaction is the ferric chloride test. In practicals also we do that one, ferric chloride test, where violet color complex is. When phenol is reacted with uh, ferric chloride solution, then it forms iron phenol complex. FeOC6H5 is Hol 6, and this complex has the violet color. And this ferric chloride test is not given by the benzoic acid. Benzoic acid don't give this test. So for benzoic acid, what we will take? But benzoic acid react with the neutral FeCl3. उसकी reaction किससे कराएंगे? Neutral FeCl3 से. Okay. It gives buff colored PPT. It gives another test with neutral FeCl3. It forms the buff color compound. So in this way, we distinguish between the benzoic acid and the phenol. Clear? Now next or question of this part. Yes, this is the last one. Or in all that one long answer, you are given the internal choice. Now read carefully this one. An organic compound A with molecular formula C3H7NO on heating with Br2 and KOH forms a compound B. Okay. Compound B on heating with chloroform and alcoholic KOH produces foul smelling compound C. On reducing with benzene, that Hinsberg reagent, benzene sulfonyl chloride forms a compound D, which is soluble in alkali. Write the structure of the A, B and C and D. Now this is wording question. We call that we have to identify A, B, C and D. As you see the formula C3H7NO, first try to form its chemical formula. Now 3 carbon means propane will be there, 3 carbon chain, 1 oxygen and 1 nitrogen. It must be amide. It is propanamide. CH3, CH2, CO, NH2. Now next part, what it is telling. Now one by one you have to read the line, then you have to make the equation. It is telling react it with Br2 and KOH, alcoholic KOH. As soon as you see the Br2 and alcoholic KOH, identify that Hofmann bromamide reaction. Now amide is given. When we do the Hofmann bromamide reaction, what happens? That is degradation reaction and primary amine is formed. So what will the formation? CH3, CH2 and NH2 will be formed. So A is or this amide, B is or ethylamine. Okay. Now next part, what it is telling? B react with chloroform and alcoholic KOH. As you see the alcoholic KOH and chloroform. We all know very famous reaction, carbylamine reaction, where the isocyanide is formed. So here the formation of isocyanide, CH3, CH2 and C. Ethyl isocyanide. So our C will be the ethyl isocyanide. Then last line, what is telling? B when react with this Hinsberg reagent. Your amine when it react with that one Cl SO2 benzene. Here we write direct C6H5. This is your Hinsberg reagent. Here one HCl will be removed from here, minus one HCl. And as it is, this group will attach. So what will form? CH3, CH2, see there. NHSO2C6H5. That is your ethyl benzene sulfonamide. What is the D product? This is ethyl benzene sulfonamide product will be formed. Okay. So we have to identify ABCD. We have completed. Now give reasons to support your answer. Presence of alpha hydrogen in aldehyde and ketones is essential for aldol condensation, because alpha hydrogen is replaced by that one and convert into OH group. The alpha hydrogen atom are acidic in nature due to presence of electron withdrawing carbonyl group. On this one, C double bond H, electron withdrawing group, carbonyl group. This can be easily removed by the base and the carbanion formed by resonance stabilized. This H can be easily removed. That's why your aldehydes are more reactive than the ketones. Okay. Next, 3-hydroxy-pentane 2-on shows positive result to tolerance test. Now, as though you have given the, wait up this part. Yes, 3-hydroxy-pentane 2-on. First pentane 2-on given to make the 5 carbon chain 4 and 5. Here given 2-on, this is 2-on, 3-hydroxy, so 1, 2, 3, this is OH, and fulfill all other valencies with the help of hydrogen, CH3, CH2, then here CH and your CH3. If you check it, that one, this is functional group carbon, alpha carbon, that functional group carbon is alpha carbon here. So 3-hydroxy-pentane 2-on. We have made up the formula 3-hydroxy. This is alpha hydroxy ketone. What is it? Alpha hydroxy ketone. And alpha hydroxy ketones have nature to undergoes tautomerism. This type of isomerism, tautomerism. So this ketone group convert into the your aldehyde group. This ketone group convert into aldehyde group by the tautomerism, and that's why if aldehyde group is present, then it can easily give the positive tolerance test, and that's why 3-hydroxy-pentane 2-on will give you positive tolerance test. Clear to everyone? Now we have solved the complete this paper. I think it will be very useful to you. Thank you everyone.